Hello, 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 and welcome back to the stream. Today we are going to try and complete the Godot 3D game tutorial from the Godot docs. So, uh, sorry, let me just take care of one thing I forgot to do real quick. Okay, got that out of the way. So I've got everything up and running, so we can just immediately get started. I did want to point out that I went ahead and added a quick little timer at the top here that indicates how long I will be streaming for. Didn't know where I wanted it on this stream, so I'm just going to kind of, where's that going to not be in the way? Let's put it down here. Yeah, that seems like a good place to have it. So our goal is to go ahead and complete this. And if we have enough time, then I've got Lucidcharts open here. And then we can go ahead and go through and try and come up with a decent idea for a game that we can start designing and developing for our next several Coding Fridays. So, last week we were developing the 3D game, which was the same as the 2D game in essence. Where is it? Content. That's the setting up. No, I just want to... Where is it? Oh, here it is. Where it's kind of similar to this, except in 3D fashion. And we got to the point where we could move the character around and we were spawning the creeps. What we hadn't been doing is be able to do the jumping. We couldn't kill the creeps. We couldn't die. And we had this bug where if the creeps ran into each other, they would just hit each other and then stay. So we have to somehow deal with that as well. So, yeah. Just going back real quick, making sure, because that's removing the mobs off screen. So that does the initialization. Velocity. Yep. Okay. So the next portion that we were going to jump into is controlling the physics and interaction for jumping and squashing. So just so you all can see it, this is where we ended up last time. See, as the creeps started running into each other, they would hit and then they would just stop. And then I could run into them and nothing would happen. So then the screen kind of just gets filled up. So hoping that the next bit of tutorial will handle the rest of this. So let's go ahead and just jump right into this. So jumping and squashing monsters. In this part, we'll add the ability to jump and squash the monsters. In the next lesson, we'll make the player die when a monster hits them on the ground. First, we have to change a few settings related to physics interaction. Enter the world of physics layers. Okay. So this is the documentation in Godot that just kind of describes the physics. Controlling physics interaction. Physics bodies have access to two complementary properties, layers and masks. Layers define on which physics layers an object is. Masks control the layers that a body will listen to and detect. This affects collision detection. When you want two bodies to interact, you need at least one to have a mask corresponding to the other. If that's confusing, don't worry. We'll see 3 examples in a second. The important point is that you can use layers and masks to filter physics interactions and control performance, and remove the need for extra conditions in your code. Hey, Sky Panda, welcome to the stream. By default, all physics bodies and areas are set to both layer and mask 1. This means they all collide with each other. Physics layers are represented by numbers, but we can give them names to keep track of what's what. Setting layer names. Let's give our physics layers a name. So we go to Project and Project Settings. So we're here. In the left menu, navigate to the layer names. Layer names. We're here. 3D physics. You can see a list of layers with a field next to each of them on the right. You can set their names there. Name the first 3 layers player, enemies, and world respectively. Coding object collisions or basic physics of objects. A little both. The layer names are the physics of the objects and the worlds themselves and how the objects interact with each other, which includes the actual collisions themselves. So you need the physics layers of the world, I guess, the basic physics of the objects and the world in order to code the collisions properly, if that makes sense. So they want us to do layer 1 is going to be a player, layer 2 is enemies, and layer 3 is world. So layer 3 would be that ground layer. Layer 2 is the enemies, the mobs that get created. Layer 1 is our player creation. Now we can assign them to our physics nodes. So let's close that. In the main scene, that's this one right here. No, this one right here. Right? Inspector of the main scene. Yeah. In the main scene, select the ground node. Makes sense. In the inspector, expand the collision section. Collision object 3D. Okay, that's this section right here. So this is actually going to be... Okay, see how the layer is defined as 1, 2, 3, 4, all the way down to 16. And here in project settings, we have 1 through 32. You can actually click to expand that to have more. So you can define a very specific layer. So we're going to most likely, if I going to make the assumption, there you can see the nodes layers and masks as a grid of buttons. The ground is part of the world, so we want it to be part of the third layer. Click the lit button to toggle off the first layer and toggle on the third layer. So if I do that and that. Oh, so you can actually have multiple layers. So I could essentially have the ground layer. Oh, all right. I think I'm starting to understand a little bit. So rather than having the conditional logic within the code to handle how objects interact with each other based off collision, we can handle the logic based off the layer. So I just write the code once. For instance, layer 1 interacts and has a specific interaction with layer 2. So as I create new objects that have the same interaction with layer 2, the enemies, then I just add that layer physics to the collision object. That's actually pretty neat. I like that. I like the being able to reduce code, duplicate code. All right. The ground is part of the world. Okay, we did that. Then toggle off the mask by clicking on it. Okay. No mask. As mentioned before, the mask property allows a node to listen to interaction with other physics object, but we don't need it to have collisions. Ground doesn't need to listen to anything. It's just there to prevent creatures from falling. Note that you can click the ... button on the right side of the properties to see a list of named checkboxes. So this right here. Okay. Next up are the player and the mob. Open the player TSCN. So the player scene, basically. So not the art asset. We want player. Okay, so we want the player node and go to... Okay, so that's the player node. So same thing, we're going to go down to collision here. Set the player node and set the collision mask to both enemies and world. So we are not going to be interacting with myself, which is the player, but my physics is the layer. Okay, so we are going to interact with the world, and we are going to interact with enemies. That's good. So now we go to the mob scene, and so we go to objects, collision, and we do that. And the mob is not going to listen to the player. Set its collision layer to enemies and unset its collision mask, leaving the mask empty. These settings mean the monsters will move through one another. If you want the monsters to collide with and slide against each other, then turn on the enemy's mask. All right. So let's go ahead and see how this looks right now. Did it all break? Oh. I got pushed off. Yeah. The enemies are now flowing through each other. We're still interacting with the world, so we're staying above. And we can still run into the enemies. Okay. It's good. It's good. All right. The mobs don't need to mask the world layer because they only move on the XZ plane. We don't apply any gravity to them by design. All right. The jumping mechanic itself requires only 2 lines of code. Open the player script. That's this. All right. Man. Let's see. We need a value to control the jump strength and update underscore physics process to code the jump. After the line that defines fall acceleration, that's right here, at the top of the script, add jump impulse. So add export var jump impulse. We set that to 20. All right, so vertical impulse applied to the character upon jumping in meters per second. Okay. We're going to have to mess with this just to see what the actual difference is if we change that. Okay, so before the move and slide, we want to add okay. So we have the if not is on floor. So right here, we'll do the if is on floor and input dot is action just pressed, and we want jump colon. So then target velocity dot y is going to equal the jump impulse. So that adds 20 to the y velocity on the target. Where here, the target velocity is getting the xz right here. Follow the acceleration. Okay. So let's save it. All right, before I read this next portion, let's just go ahead and give it a shot. Oh, look at that. I am jumping. Look, look. Little hops, little hops. Okay. So let's find, let's see, it's under node. No, we want the player scene. Okay, let's update this. So let's turn this into 50. And the reason why is we're going to overwrite it so we can see catching a ride. Yeah, that is not loading. Why is it always like this? Okay, come on. We have to run the main. Whoa. That is. Okay. That was. Whoa. What are those? Did you all see that? When I go in the air, these things. Oh, I get it. I get it. So we set it up so the mobs will look at the character. So when I'm in the air and the mobs spawn, they actually point up in the air to look at me. That's kind of funny. That is a little funny. They're like little sharks swimming through the water. That's. I'm having too much fun with this. Okay, so that's a decent test. At least for me, that was a decent test. So what this does right here is indicating how far on the y-axis I am actually jumping when I hit the jump, the spacebar, basically. So it's a 50 meters per frame, essentially, or per second. So that is based off delta. So yeah, so we'll put this back down to 20. Save it. All right. The is on floor method is a tool from the character body 3D class. It returns true if the body collided with the floor in this frame. That's why we apply gravity to the player. So we collide with the floor instead of floating over it like the monsters. If the character is on the floor and the player press jump, we instantly give them a lot of vertical speed. In games, you really want controls to be responsive, and giving instant speed boosts like these, while unrealistic, feels great. Notice that the y-axis is positive upwards. That's unlike 2D where the y-axis is positive downwards. Alright, now we're going to do squashing monsters. Let's add the squash mechanic next. We're going to make the character bounce over monsters and kill them at the same time. We need to detect collision with a monster and to differentiate them from collisions with the floor. To do so, we can use Godot's group tagging feature. Oh, this is new. We haven't done this yet. I'm going to grab some water. Open the mob scene. Select the mob node. All right, we're here. Go to the node dock. I think that's this one. Oh, groups. All right, we have done something in groups before. To see a list of signals, we have scene groups and global groups. The node dock has two tabs: signals, which you've already used, and groups, which allows you to assign tags to nodes. Click on it to reveal a field where you can write a tag name. Enter mob in the field and click add. Mob. Okay. I think the screenshot's older. Because this, yeah, this definitely looks older. Because you can either set it global or scene groups. Let me check community notes real fast. One has to click the plus sign next to filter groups, and then they can create a new group. For loop, skipping that, collision detection. Okay. No one says to put it in the global groups, so we'll just add it to the scene groups. An icon appears in the scene dock to indicate the node is part of at least one group. Okay, node is in this group mob. We can now use the group from the code to distinguish collisions with monsters from collisions with the floor. Coding the squash mechanic. Hey, dishwasher, swisher. How you doing? How do we get Toofy Donuts in here? Oh, if Toofy outputs his donut, I could import his actual GLB, and yeah, that's pretty much all I need. I want some donut PvP. Yeah, if he basically is like, he just needs to export it and then that'll be good. Because the art assets that they have right here is a .glb, which is basically a packed scene. Rings versus Donut Bites Battle Royale. I would like to take this a little bit further and see how to use an animation. So that way we could get a donut that does something like this. Kind of like a Pac-Man type thing. Except it's a donut that eats you. You can have donuts eating donuts. Maybe a copper donut? A cop donut eating another cop donut? Sorry, you're getting me all distracted now. Donuts eating small babies and cops. And their only weakness is coffee. All right. I'm getting super distracted now. All right, head back to the player script. On the player script, at the top of the script, we're going to add the bounce impulse. All right. So this is once we var bounce impulse go 16. Okay, then after the jump code block, we added above and the following loop with move and slide. Godot makes the body move sometimes multiple times in a row to smooth out the character's motion. So we have to loop over all collisions that may have happened. In every iteration of the loop, we check if we landed on a mob. If so, we kill it and bounce. With this code, if no collisions occur on the given frame, the loop won't run. Okay. For loops. For index in range. Get slide. Collision underscore count. Yeah, this language definitely feels like a combination of JavaScript and Python with a little bit of Go. Null continue. So, all right. So let's look at each line right now. So the for loop, iterate through all collisions that occurred this frame. If we get one of the collisions with the player, we grab it by index. If the collision is with the ground is equal to null, then we break out oh. We don't break, we just do a continue. Okay. Why would we not break? Interesting. If the collision is with ground, you just continue? Weird. I'm not 100% sure why that's like that. I would think that as long as this right here, this is in group mob, that this conditional right here, if collision get collider is in group, that makes me feel like that should be where the continue is. Because because continue makes you keep going through the for loop. A break exits the for loop. I don't know. Well, yeah. Or pass. Yeah, exactly. Well, let me get this code in and then we'll read the next portion. Maybe they explain why they did it this way. Dirt3 dot up dot collision normal greater than 0.1 dot squash. Velocity.y. So that makes us bounce back up. Sorry, I'm rereading through this code, trying to understand it. If the collider is with a mob, we check that we are hitting it from above. Okay. If so, we squash it and bounce. Prevent further duplicate calls. All right. This would indicate that for this frame, we're only going to bounce one time. Which means that this for loop is not really iterating all collisions then. It's looking for the first collision with a mob. This... Okay. So collision here, they're using the index on get slide collision. Okay. I think I understand it. So essentially, they're using a for loop not to really use it the way that most people would use a for loop. It feels really hacky because of the get slide collision count. So per frame, they need to check all the collisions when really they just want to see whether or not they collided. Missed the part for the deep fry. For the donuts. That's right. That could be like an environmental trap or something. The deep fryer. Or that could be where you start. It's like you start as dough that drops into the deep fryer and then you pop out ready to go. And your power up could be like frosting getting dripped on you. So yeah, to me this feels a little hacky, but that might be just the way Godot is set up because what we really want to do is just be able to check if we have collided with a mob. But in order to do that, we have to grab an index on the slide collision, which means that we have to do a for loop to grab an index. So what we're doing is for the frame, we have to keep cycling through all the collisions that the player has, which may include like 5 collisions with the ground and then 1 collision with a mob. So, okay. That's a lot of new functions. Here's some more information about them. The functions get slide collision count and get slide collisions both come from the character body 3D class and are related to move and slide. Get slide collision returns a kinematic collision 3D object that holds information about where and how the collision occurred. For example, we use its get collider property to check if we collided with a mob by calling is in group. On it, collision.getCollider is in group mob. Is in group is available on every node. To check that we are landing on the monster, we use the vector dot product. The collision normal is a 3D vector that is perpendicular to the plane where the collision occurred. The dot product allows us to compare it to the up direction. With dot products, when the result is greater than 0, the two vectors are at an angle of fewer than 90 degrees. A value higher than 0.1 tells us that we are roughly above the monster. After handling the squash and bounce logic, we terminate the loop early via the break statement to prevent further duplicate calls to mob.squash, which may otherwise result in unintended bugs such as counting the score multiple times for 1 kill. We are calling one undefined function, mob.squash, so we have to add it to the mob class. Open the mob script by double clicking. Yeah, okay. We want to define a new signal named squash and at the bottom you can add the squash function where we emit the signal and destroy the mob. Okay. Squashed. Funk squashed. So squashed dot emit. And then we're gonna queue free. Did I miss something? Oh. Squash. Can't name it the same as the signal itself. What's next? We will use the signal to add points to the score in the next lesson. With that, you should be able to kill monsters by jumping on them. You can press F5 to try the game and set main as your project scene. So if I hit 5, select main, open. Oop. Oh. Uh, I can't. I'm really bad at this. Come on. A little bit when I'm in the air. Boop. Boop. Okay. That's good. However, the player won't die. We'll work on that in the next part. All right. We're moving on to killing the player. The first jump was high, the next jump was short, the next was high, and so on. Hey, Quellis Dev. Welcome, welcome, welcome. Yeah, this is my third stream of Godot. I gave you full credit for me jumping into this. I'm giving this a shot. First stream, we did the 2D game docs. Second stream, we did the first half of the 3D game. And now this stream, we're going to finish off the 3D game tutorial. And then, after that, Quellis Dev, Dishwasher's name is so hype. So, yeah, once we finish this game, I'm going to take some advice and suggestions from chat, and hopefully we can come up with some ideas for designing a simple 2D, possibly shooter game. Yeah. And then we can focus on trying to do that for the next several Coding Fridays. It's like combo, but dishwashing. Dishwasher. I get nervous washing dishes. Killing the player. We can kill enemies by jumping on them, but the player still can't die. Let's fix this. We want to detect being hit by an enemy differently from squashing them. We want the player to die when they are moving on the floor, but not if they're moving in the air. We could use vector math to distinguish the two kinds of collisions. Instead, though, we will use an area 3D node, which works well with hitboxes. Head back to the player scene. Player scene. And we're going to add a child node of an area 3D. And we are going to name it Mob Detector. Detector. Yep. And then I forgot what the shortcut was. Control A. All right. And then we will add a collision shape 3D. And we want to add a new cylinder type. Empty, new cylinder shape. Okay. All right, here is a trick you can use to make the collisions only happen when the player is on the ground or close to it. You can reduce the cylinder height and move it to the top of the character. This way, when the player jumps, the shape will be too high for the character to collide with. Okay. So we go here. So they're saying we take this. Oop. Oh, that's elongating it. Where's my move? That's scale. That's rotate. That's move. Okay. Is this? There. No. There. Okay. Shrink it down. And then we want to scale this out. There's a scale. There's a scale. Nope. Or is it that button? No. That's going that way. Is it that one? Yeah, there we go. Let's move it back down. Let's hide that one, and yeah, let's hide that so we can actually see a little bit better. So we're going to increase the size a little bit more so we can actually get around it. Okay. Oops. That look about. Feel like I can move it a little to the left. Why do I have to be so OCD about this? So bad. So bad. That's Quillis Dev. You a secret Godot dev too? Quillis is the one who told me about Godot. He uh, he and his buddy collaborate together and actually stream development constantly. And they were working on a game together. I'm pretty loudly a Godot dev. Maybe later you can give me a little advice on how to like scroll the background with the player kind of like not really moving off the screen, or maybe on a side scroller where the map screen keeps moving, but then when it gets to the edge of the map, you want the screen to kind of stop. Yeah, yeah. Essentially, think of it kind of like Mario Brothers, the original, where the camera follows the Mario, but then when you get to the castle at the very end, the screen stops. Kind of want to do the same thing with a 2D shooter, kind of like this, and then the background and everything is moving kind of downwards like this, and then when you get to a boss, then it just stops. That's one of the thoughts I had in mind, but I wasn't quite sure how to manipulate the movement of everything properly. All right, that looks good to me. All right, so I have it above. You also want the cylinder to be wider than the sphere. This way, the player gets hit before colliding and being pushed on top of the monster's collision box. All right, you know what? Let's go ahead and make it just a little bit bigger. Next, select the mob detector. Turn off its monitorable property. This makes it so other physics nodes cannot detect the area. The complementary monitoring property allows it to detect collision. Then remove the collision layer and set the mask to enemy layer. Remove that and set it to that. Dishwasher. When areas detect a collision, they emit signals. We're going to connect one to the player node. Select mob detector. Go to the inspector node. Double click the body entered. Oh, node tab. Bodied entered. Where is it? Entered. There it is. Connect it to the player. Connect to player. Yeah, the mob detector will emit body entered when a character body 3D or rigid body 3D node enters it. Please ask first when a rigid body enters. As it only masks the enemy's physics layer, it will only detect the mob nodes. Code-wise, we're going to do two things. Emit a signal we'll later use to end the game and destroy the player. We can wrap these operations in a die function that helps us put a descriptive label on the code. So we're going to emit a signal. Hit Quillis Dev. I haven't done much fancy camera stuff like that yet. Dishwasher. Probs why people like that. Resident Evil static camera. Yeah. Bunk die. Oh. Hit emit and Q 3. You know what? Let's go ahead and get that in there. And then here, we're just going to call die. The stream time. Sorry, I should just I should just allow that. I don't know why, but the stream timer makes me feel like someone called a nuke and I got a GTFO. Quellis Dev, I think you said no backseating mode, so I shouldn't type out my thoughts just yet. Nah, go for it. I need to make you a mod, Schwasher. Else are we supposed to peanut gallery? Exactly. And plus, if you have thoughts, really you're commenting on the Godot official docs. It's not on me. It's not my fault. I'm just following the docs. How? Ooh. A quick solution, which is what I've done so far, is just to make a camera a child of the player so it follows. Oh, okay. And then once you hit a certain point, is it kind of like once it hits a certain position in the map or something, like a collision of that camera with another camera on the map, then it kind of switches or something? Isn't that how it normally is done in like Unity? Maybe. Okay, we can use the player's hit signal to end the game. All we need to do is connect it to the main node and stop the mob timer in reaction. Open the main scene. Okay, here's the main scene. And select player. And in the node dock, connect its hit signal to the main dock. Main node. Connect. That sounds fancy. Let us clip through walls, Daddy. You know what would be fun? To make an impossible game to finish, but then actually create it so that only speedrunners can complete the game. Purposely add specific bugs so that only speedrunners can complete it. But for the fancy camera stuff, I'm thinking you're better having the camera separate with a script that knows the player's position and map info and moves the camera accordingly. Okay. Rather than the main scene just following the player and keeping the player in the middle of the scene. I guess that kind of makes sense. One thought I was also having was just make the background a animation where it looks like it's moving, and then have a timer going for how long the level is actually supposed to be. And then once that pops, then the background changes to the final scene and then the boss comes in, type of thing. Dishwasher, yeah, like if you have multiplayer, how does that work? Am I overcomplicating it? Just a bit. You're like, hey, why don't we go to the Olympics and sprint after sitting on our butts for, I don't know, 8 years just eating Cheetos, watching on Netflix? Why aren't we planning for deep fried Call of Duty? You could totally do it as a child of the player. The ways I can think of doing it are kind of messy. It's all good. It's all good. We can figure it out. And maybe sometime we could bring you on as a guest to one of our streams because Did a Dishwasher wants to do a Thirsty Thursdays coding session. What was I doing? Oh, finishing up this mob timer. Mob timer dot stop. So once we hit, we stop the timer, which ends up on mob timer timeout. We instantiate, but then we just stop the timer, which then no more mobs get created. Okay. If you try the game now, the monsters will stop spawning when you die, and the remaining ones will leave the screen. All right, let's try it out. All right, F5. Boop. And they all left the scene. Okay. So that works. Just for the record, if anybody on here is not a software dev or is just getting into it, test early, test often. You don't want to get through an entire code or your entire game and then test and nothing works. Test early, test often. Plus, it's also really fun to see things slowly progress. Good advice. Dishwasher. Don't piss off Streamlabs. You did it again. Also note, okay. Mob timer. Also note that the enemy colliding with the player and dying depends on the size and position of the player in the mob's collision shapes. You may need to move them and resize them to achieve a tight game feel. Actually, let's test that again. No, that felt right. Streamlabs is just not going to let you speak anymore, Dish. What I was trying to say, fact that test in prod with live users. That's like, hey, I need to do a data migration. We're not going to test my script in dev or in a sandbox. Let's just go ahead and run my migration script against a live database against users. Like the only people who need tests are those not confident in their skills. Right. It's not the fact that there's like 20-year-old legacy code that You had to hack stuff around because other people had to hack stuff to get it running in the first place. And it wasn't project managers that kept rushing people, not letting you actually build things properly. No, no, no. Couldn't be that. Not at all. All right. Enough griping about that. Let's get back to Godot. You can pat yourself on the back. You prototyped a complete 3D game, even if it's still a bit rough. From there, we'll add a score, the option to retry the game, and you'll see how to make the game feel much more alive with minimalistic animations. I think Dishwasher was the engineer at CrowdStrike. Dishwasher told me to apply to CrowdStrike. Here are the complete scripts for the main mob and player nodes for reference. You can use them to compare. We're going to skip that because I think we're fine. Blah, blah, blah. And moving on. Hashtag skill issue. Score and replay. All right. We're just getting a little bit further and we're almost there. Score and replay. In this part, we'll add the score, music, playback, and the ability to restart the game. We have to keep track of the current score in a variable and display it on the screen using a minimal interface. We will use a text label to do that. In the main scene, add a child node control to main and name it user interface. Sure. Control node. And F2 for user interface. It was just one change. Ensure you are on the 2D scene where you can edit your user interface UI. Okay, here we are. Okay, so add a label node and name it score label. Label. I like the shortcuts. Once you learn the shortcuts, I can feel this going really, really quick. In the inspector, then we do score 0. Also, the text is white by default, like our game's background. We need to change its color to see it at runtime. Scroll down to theme overrides. Theme overrides. Okay, where is theme overrides? Under control. Theme overrides. Here we go. Colors. Font color. Enable font color in order to tint the text to black, which contrasts well with the white 3D scene. Well, you know me. We can't go with just black. We are going with... Yeah. Where is it? Where is my purple? Right about... Yeah, there we go. Perp. Always perp. Gotta have my purple. There we go. As you can see, it is right there. Just so I can see it better. Okay. Finally, click and drag on the text in the viewport to move it from the top left corner. Okay. The user interface node allows us to group our UI in a branch of the scene tree and use a theme resource that will propagate to all its children. We'll use it to set our game's font. Okay. Want them double fried tonos with a perp sprinkles. Yeah, that'd be nice. Creating a UI theme. Once again, select the user interface node. In the inspector, create a new theme. New theme. Okay, click on it to open the theme editor, which is down here at the bottom. All right, it gives you a preview of how all the built-in UI widgets will look with your theme resource. Okay. Whoops. By default, a theme only has a few properties: default base scale, default font, and default font size. You can add more properties to the theme resource to design complex user interfaces, but this is beyond the scope of this series. To learn more about creating and editing themes, see Introduction to GUI Skinning. That'd actually be pretty good. All right, the default font expects a font file like the ones you have on your computer. Two common font file formats are TTF and OTF. In the file system doc, expand the fonts right here directory and click and drag TTF we included in the file onto the default. Where is default font? Oh, that's over here. Is that here? This middle one? Yeah. Okay. Change this to 22. Excuse me. Sorry about that. All right. So we got that. We got the theme all set up. That seems to be fine. So this theme, I guess we overrode the font, but I think it updated all that as well, right? I wasn't paying attention. I think it did. Let's see the score. Let's work on the score next. Attach a new script to the score label and define its score. Score label. Create. Our score equals 0 because that's the starting value. The score should increase by 1 every time we squash a monster. We can use their squashed signal to know when that happens. However, because we instantiate monsters from the code, we cannot connect the mob signal to the score label via the editor. Instead, we have to make the connection from the code every time we spawn a monster. Open the script main. If it's still open, you can click its name. Okay. Alternatively, you can double click. Whatever. At the bottom of the on mob timer timeout, add the following line. We connect the mob to the score label to update the score upon squashing one. Okay. Why? Why can't we just do... Thinking about this for a moment. Okay. So the objects are individually created, instantiated. So the signals are not generic signals. Right? So mob timer has a signal to there. Player is receiving a signal. So mob squash dot connect. That has a hit signal. Mob has a squash signal. Okay, there's a single player. Okay, because there's a single player, then we can attach that signal. So when that player gets removed, then the main can actually do something with it. So we can attach that. But because there's multiple mobs that get instantiated multiple times, or at any time, then each mob has a different signal attached to it. They own that signal. So there isn't just a generic signal that gets sent off. It's not a global signal. Oh, that's interesting. I would have thought that we could. Huh. I really thought that we would have been able to. Let's see, mob squashed. Yeah, I would have thought that there would have been able to create a global signal, but I guess it is tied directly to a single object. I'm still trying to learn the language and everything, so I have to stop and just think about the logic and why things are done the certain ways. So, all right. So this line means that when the mob emits the squash signal, the score label node will receive it and call the function on mob squashed. So every single time we get a mob is created, we're manually connecting that signal. Head back to the scored label right here. Head back. Script to define the on mob squashed. Okay, so on function on mob squashed. So this is what's different about having to manually connect and bind a signal. Instead of Godot automatically adding the function for us, we have to go in and create it ourselves. So score plus equals 1. And then we reset the actual score. Hey, dishwasher. I don't remember, but that's Python's formatting for print statements, right? Wonder what the sys performance looks like once you scale to 40k donuts. Jesus. Close. Okay. That's what I thought. Print. Right, right. Because it's a function. But I mean, if you were setting it to a variable, like a string to a variable, that's one way you could do it. I mean, the other way is with the pluses in between. Okay. All right, second line, value score gets added. Then we replace the placeholder. Godot automatically converts values to string text, which is convenient when outputting text in labels or when using the print function. You can now play the game and squash a few enemies, possibly. I think the other way is score. Oh, yeah. Format with that. Okay, yeah, that makes sense. You can now play the game and squash a few enemies to see the score increase. Okay, let's try it. Whoop. Oh, I died. And I killed it. Let's try it again. Oh, that's actually a little hard. All right, I'm going to move 2D. Where is my main scene? 2D. Come on. Did I get there? Yeah. Oh, getting wrecked. All right. In a complex game, you may want to completely separate your user interface from the game world. In that case, you would not keep track of the score on the label. Instead, you may want to store it in a separate dedicated object. But when prototyping or when your project is simple, it is fine to keep your code simple. Programming is always a balancing act. Yeah, I would probably create this as a separate scene and then just import it kind of like the way we did with the player here. All right, now we're going to retry the game. We'll now add the ability to play the game again after dying. When the player dies, we'll display a message on the screen and wait for input. Head back to the main scene, right here. And select the user interface. Add a child node color rectangle. Okay. Color rec. And name it retry. This node fills a rectangle with a uniform color and will serve as an overlay to darken the screen. To make it span over the whole viewport, you can anchor preset. Right there. Nothing happens. Well, almost nothing. Only the 4 green pins move to the corners of the selection box. This is because UI nodes, all the ones with green icon, work with anchors and margins relative to their parent's bounding box. Here, the user interface node has a small size and the retry one is limited by it. Select the user interface and apply anchor preset full rect. Right here. Full rect. Okay. Now let's change the color so it darkens the game area. Select retry in the inspector. Set its color to something both dark and transparent. This. All right. In the color picker, drag the A slider to the left to control the color's alpha. It controls the color's alpha channel, that is to say, its opacity transparency. Okay, so we don't want it all the way to the left. We're going to go black. darken it to about here. I'm basing it off that color right here for the score to look a little darker. Yeah, right there. Next, add a label as a child to retry. Okay. Label. Give it the text press enter to retry. Press enter to retry. And move it and anchor it to the center of the screen. Anchor center. There we go. Okay, we can now head to the code and hide the retry node. When the player dies and plays again. Open the script to main. Script main. First, we want to hide the overlay at the start of the game. Add this line to the underscore ready. Func underscore ready. So the user interface, retry dot hide. So then when the player gets hit, then we want to show it. So I guess it doesn't really matter which direction we go. We can either stop the timer first or show the retry first. Okay. Finally, when the retry node is visible, we need to listen to the player's input and restart the game. If they press enter to do this, we use the built-in unhandled input callback, which is triggered on any input. If the player pressed the predefined UI accept input action and retry is visible, we reload the current scene. Okay. So func unhandled input. All right. We don't. If the event is an action pressed, UI accept, and user interface retry is visible, then get tree dot reload current scene. The function getTree gives us access to the global scene tree object, which allows us to reload and restart the current scene. So that's this whole tree. Because the player's on here, spawn path, and it restarts the mob timer. So everything starts from scratch. And since main is running the entire game, that would start everything. Okay. To add music that plays continuously in the background, we're going to use another feature in Godot, auto loads. To play audio, all you need to do is add an audio stream player node to your scene and attach an audio file to it. When you start the scene, it can play automatically. However, when you reload the scene, like we do to play again, the audio nodes are also reset, and the music starts back from the beginning. You can use the auto load feature to have Godot load a node or a scene automatically at the start of the game. outside the current scene. You can also use it to create globally accessible objects. Create a new scene. Okay. And we want other node. We're saying it's going to be a audio stream player 3D. I guess 3D player? I don't, I don't. What does it matter if it's 3D or TD? I'm not sure. Music player. Maybe 3D determines directional? Okay. So now we included a music track in the art house in the forest loop. Click and drag it onto the stream property in the inspector. Okay, that's right up there. Click and drag it on it. Okay. Also turn on autoplay, the music automatically at the start of the game. Autoplay, autoplay. Where is autoplay? It is right here. Autoplay. Save the scene. Okay. Music player. Yep. We have to register it as an auto load. Head to the project settings. Click on auto load. Okay. Auto word. Wait, where is auto load? Because they have it at the very top. Input map localization. Is it under globals? Yeah, there. Okay. Auto load is now under globals. This is the wrong screenshot. All right, in the path, you want to enter the path to your scene. Click the folder icon to open the file browser and double click the music player. 3D is if you're doing 3D stuff, and 2D is if you're doing 2D stuff. Well, obviously, but I'm trying to understand like what's the big difference between doing 3D music versus 2D music? I mean, can't you mix and match a 2D music with a 3D scene or a 3D game? Or will there be end up being a conflict with it? Music player scene. Because one of the reasons I'm asking is because the UI stuff is all 2D. Okay, so we added that. That's here, music player node. Now loads into any scene you open or play. So if you run the game now, the music will play automatically in any scene. Before we wrap up this lesson, here's a quick look at how it works under the hood. When you run the game, your scene dock changes to give you two tabs, remote and local. When you run the game, scene changes to give you two tabs, remote and local. The remote tab allows you to visualize the node tree of your running game. There you will see the main node and everything the scene contains and the instantiated mobs at the bottom. At the top are the auto-loaded music player and the root node, which is your game's viewport. And that does it for this lesson. In the next part, we'll add an animation to make the game both look and feel much nicer. Here's the completed code. Okay. So this is the next part. I'm going to go ahead and I am going to make a slight change to my mobs. Starting position. I'm not hearing the music. And I'm not even pressing enter for it to do the retry. I'm just pressing space. But it does do the reset properly. Okay. So that's all working. Something that I want the mobs to be slightly above. Initialize. Look at from start position, gets the location, rotate. I don't like it. I think I'm missing something. Definitely feel like I'm missing something. Code check. This is main. Rand F. Good question. I don't know about the music player specifically. Audio players have a counterpart audio listener and change the volume panning based on their relative direction. So mixing 2D and 3D wouldn't they wouldn't know how to calculate it. Yeah, that's what I was thinking that 3D I think would only be really important if it was doing directional sounds type of thing. So if you were creating a game where sound was important, such as like a horror game, where your enemies need to be sensitive to where sounds were coming from, that would be one of those things. Okay, so initialize spawn position, player, instantiate, like Panicore, possibly, yeah, Panicore. Mob, divide by forward, min speed, forward, random speed, up, rotation Y, start position vector 3 dot up. Rotate it towards the player position so it looks at the player. Rotate the mob, range of 45. Calculate at random. We calculate a forward velocity and represent the speed in order to move in the direction. Uh, let's try this. Velocity dot y plus equals 1. I just want to see what this does. Equals 1. Fixes process. Let's try that again. They're slowly going up. Okay. That didn't work as I thought it was going to work. Unless it didn't pick up my change. Hey. Hmm. I want to initialize it. Why is it changing the up direction? Let's try that. Okay. I want it a little bit. Oh, why did I do that? I want it a little bit off the ground. They're slowly going too far up. Like slowly taking off. Whatever. I'm over it. Okay, where are we at? Character animation. Oh, they actually have theirs jumping. All right, in this final lesson, we'll use Godot's built-in animation tool to make our characters float and flap. You'll learn to design animations in the editor and use code to make your game feel alive. We'll start with an introduction to using the animation editor. Using the animation editor, the engine comes with tools to author animations in the editor. You can then use the code to play and control them at runtime. Open the player scene, select the player node. Okay, first, player scene, player node, right here, and add an animation player node. Animation player node. The animation dock appears at the bottom panel, or in the bottom panel. See, it features a toolbar and the animation drop down menu at the top, a track editor in the middle that's currently empty, snap zoom options at the bottom. Let's create an animation. Click on animation new. Animation new. Load. Okay. Once you've created the animation, the timeline appears with numbers representing time in seconds. We want the animation to start playback automatically at the start of the game. Also, it should loop. To do so, you click the autoplay button, which is this one, in the animation toolbar, and the looping arrows, respectively. Is this autoplay on load? Okay. And that's animation looping. Yeah, this is autoplay. You can also pin the animation editor by clicking on the pin button right here in top right. This prevents it from folding when you click on the viewport and deselect the nodes. Set the animation duration to 1.2 seconds. 1.2? Right here. 1.2. You should see the gray ribbon widen a bit. It shows you the start and end of the animation, and the vertical blue line is your time cursor. You can click and drag the slider in the bottom right to zoom in. There we go. Now the float animation. With the animation player node, you can animate most properties on as many nodes as you need. Notice the key icon next to the properties in the inspector. You can click any of them to create a keyframe, a time and value pair for the corresponding property. The keyframe gets inserted where your time cursor is in the timeline. Let's insert our first keys. Here we will animate both the position and the rotation of the character node. All right. Let's insert our first. Okay, select the character and in the inspector, expand the transform section. Click the key icon next to position and rotation. Okay. Create reset tracks. Create. And rotation. Create. For this tutorial, just create reset tracks, which is the default choice. 2 tracks appear in the editor with a diamond icon representing each frame. Okay. You can click and drag on the diamonds to move them in time. Move the position to 0.3. Okay. And the rotation to 0.1. Move the time cursor to 0.5. Okay. In the inspector, set the position's y-axis right here to 0.65 and the rotation to 8. You don't see the properties in the inspector. First click the character node again in the scene dock. Create a keyframe for both properties. What? What's that? Local position or translation. Okay. Wait, how am I supposed to create another one? Create a keyframe. Oh. Oh, okay. Just by hitting that again, I don't have to hit that pop up again. It just automatically created it. Now move the position keyframe to 0.7. Needs to actually be there. That needs to be there. Right? Yeah. Okay. A lecture on the principles of animation is beyond the scope of this tutorial. Just note that you don't want to time and space everything evenly. Instead, animators play with timing and spacing, 2 core animation principles you want to offset and contrast in your character's motion to make them feel alive. Move the time cursor to the end of the animation at 1.2. Set the Y position to 0.35 and the X to -9. And once again, create key pairs. You can now preview the result by clicking the play button, Shift D, right here. Click stop or press S to stop playback. Okay, you can see that the engine interpolates between your keyframes to produce a continuous animation at the moment, though the motion feels very robotic. This is because the default interpolation is linear, causing constant transitions, unlike how living things move in the real world. We can control the transition between keyframes using easy curves. Click and drag around the first two keys in the timeline to box select them. Are you able to set the easing curves for those keyframes? Oh, never mind. See the answer in the docs there. Okay, so this is what it's doing. So it has, I guess what they're saying is that it's doing a little bit of jerkiness, right? Feels very robotic. Okay. So then we stop it. So they're saying do this. Wait. Click and drag around the first two keys in the timeline to box select. Okay, I did that. You can edit the properties of both keys simultaneously in the inspector when you see an easing property. Okay, that's right here. Animation multi-track key edit. My values are a little different. Click and drag the curve, pulling it towards the left. Like that. Play the animation. Oh, that is a little bit smoother. Okay, play the animation again. See it? Apply an ease out to the second keyframe in the rotation track. That shape of curve is considered an ease out. This one right here, dragging it to the right. When they say the second set, they're talking about this one, I think, right? The first two. So, which is weird because they said that this is an ease in, this is an ease out. Oh, that doesn't feel right. That does not feel right at all. Is this it? Something doesn't feel. Did I miss something? I feel like I missed something because it still doesn't feel. Yeah, it's like it looks a lot smoother as they come down, but mine is not. It's like stopping really harsh right there, the very end. All right. No, the first two. The last one is an ease in. They wanted you to ease out the first two sets of the keyframe, then ease in the last set, aka ease out, ease in. Okay, so this is ease out. Oh, okay. All right, all right. Let's see. What is that? Doesn't it's not going all the way down, which is weird. Okay, let's look at this again. Did I do the wrong values? Okay, okay, let's stop. Okay, 0, 0, 0, 0. X is 8. 6.5. Your third position in rotation keyframe should be the same as the first. That's what I thought. All right, where's the animation? All right, character rotation. First one should be 0. That's 0. So that's my start. And then, so 0, 0 set to here and here. Okay, and then move. Okay, the inspector, Y position. This should be 0.65. That's correct. And this should be 8 degrees. Okay, that's correct. Then we moved them to here and here. All right, and then the last two position is 0.35, and this one is -9 degrees. That feels awful. Like then I highlight this, and they change that to okay. Let's just change it to what they said. 4D2. Okay. Okay. Apply an ease out to the second frame. Okay, of 4.4. See if I can get it to match. 0.35, close enough. And then for the last two, this is weird. What is this? Did they move these? Move the time cursor to the end. Set the Y positions. Key for both. Edit both properties simultaneously. Click and drag on the curve. Play the animation again to see the difference. Apply an ease out to the second keyframe in the rotation track. Oh. Oh. Maybe I wasn't supposed to change. I think what I was doing, I wasn't supposed to actually do this. I think this was supposed to be that, and then this was supposed to be coming down. 2.4, 2.7. Like, okay, that's what it was. Usually, for a looping animation or something like a jump animation, you want to end your transforms where you started or a frame before getting back to where you started. Yeah, for some reason, I don't know why they wanted it not to, because it looks really awkward, the fact that they aren't doing that. Because that little jerk at the end looks awful. Let's see. So if I stop it to the very end, we're at -9. So I almost want to go. Oh, they're trying to treat it where the loop, like the starting position of the loop, they're trying to make the starting position of the loop be the same. So it's ending on the downwards so that the loop creates it at as the beginning at the same time. But it's a weird transition because there's no smooth um there's no smoothness to actually get it to go horizontal again and then back up. So it's almost like right here. Let's see. I actually don't know how to make that a little bit more smoother, but it has that little jerk at the end. You could ease in those last two keyframes. Yeah. It's I think I need to add more keyframes though. I think the problem is that because it loops straight back to a 0, 0 from a 0.35 -9 degrees, and then it goes to 0. Yeah, I don't know. Those seem wrong. They should be the same as the first keyframes. Yeah, I think so too. Let's go ahead and stop it and give it a shot at changing them. So let's go ahead and put that at 0. And then we'll change this keyframe to 0 as well. We'll move this to 1 right here. See how that doesn't have a nice sharp downwards as it comes down. Guess that's why they did a -3. 9. What's the value of the second rotation keyframe? 8 degrees. By 8, down by 8. And the first is 0. So this is at 0. Then it points up at 8 degrees. And then we're saying it's supposed to come down at 9 degrees. And then it's supposed to flatten out at 0 again and go back up. Yeah, I just changed it to not 8 just to see what it was like. I guess that jerkiness is okay because I guess it's supposed to mimic like you're landing on something hard and it does have a like bounce to it. Like it maybe landing isn't supposed to be smooth. Oh shoot. My stream is supposed to be over. Yeah. Okay. I am going to finish this up then. Try to hurry at least. Try and ease out. Ease out. Oh, that is a lot smoother. Oh, that is a lot nicer. Well done. Thanks, Darkest. That was great. See? Coding and collaboration work hand in hand. Thank you, chat. Love it. Okay. We got that done. We're going to go ahead and try to rush through the rest of this documentation. And then starting next week, you can thank my early years as a Flash animator. Oh, Flash. If you play the game, the player's creature will now float. So let's go ahead and take a look at that. Whoa. Look at me. Oh, I died. Oh, I died. Okay. Let's see. You can use code to control the animation playback based on the player's input. Let's change the animation speed with the character is when the character is moving. Open the player script. In the physics processing, right here, after the line, we check the direction vector, add the following code. So let's see. After the line where we check the direction vector, that would be this one if the direction is not 0. So we want an else here. Animation. Animation player dot speed scale equals 1. And then we're going to copy that. And we're going to set that to 4. Okay. The code makes it so when the player moves, we multiply the playback speed by 4. When they stop, we reset to normal. We mentioned that the pivot could layer transforms on top of the animation. We can make the character arc when jumping using the following code. Add it at the end of the physics process. So pivot rotation, just copy that. Target velocity. Okay, we're going to add it right here. Nope, that's not what I meant to do. I just want that. Sorry. I'll be right back. Hey everybody, I am so sorry about that. I had a doctor call me from the VA about some appointments I needed to take care of, so I had to take that phone call because, it's the VA. So, anyways, back to the coding. I'm gonna try to get this done as quickly as I can. Don't want to try to gloss over it. So, let's see. We are adding the Let's see. The we mentioned the pivot stuff could layer transforms on top of the animation, can make the character arc when jumping using the following line of code. So the pivot.rotation.x is equal to pi divided by 6 times the velocity.y divided by jump impulse. Okay, so actually we want this after target velocity, because since we're using the actual velocity.y, we want to actually set it with the target velocity based off all the changes that we did up here. Okay. So now, animating the mobs. Here's another nice trick with animations in Godot. As long as you use a similar node structure, you can copy them to different scenes. For example, both the mob and the player scenes have a pivot and a character node, so we can reuse the animations between them. Open the player scene, select the animation player node, and then click on Animation Manage Animations. Wait, what? Animations? Manage animations? Okay. Select animation player node. Click on animation. Is this thing? Okay, there. Manage animation. Then add this thing. Manage animation. Then add library. You should see the message global library will be created. Leave the text field blank and click OK. Click the paste icon clipboard and it should appear in the window. I have no idea what that just... Did we do something wrong? Animation name cannot be empty. What? Animation. All right, we're going down here. What is this? Hey folks, if you run into an issue adding an additional animation after the initial player animation because the animation button dock isn't working grayed out, I'm using 4.2. If you unpin the dock, it unlocks the animation. Okay, I don't have an issue with that. Hope this helps. Animation. Apply the animations to the transform of the root player. Okay, I must be misreading this. Open the okay. Open the player scene, select the animation node and click animation animation node and click on animation manage animations. Click the copy animation to clipboard, 2 small squares. This one. Okay. Alongside the float animation. Click OK to close the window. Okay. Then go to the mob. Create a... All right, I was misreading that. Animation player. Child node. Okay, then we go here, manage animations. Then we say add new library. Paste? No. That didn't... Wait. Okay, go back to player, animation, manage. Copy to clipboard. Manage. Wait, why is it not paste? No. Why is it not copying into paste to clipboard? Oh. It's not a standard copy paste. It's literally an internal clipboard. Built in clipboard. Okay. Okay. I'm learning here. So the animation, you copy it with a little double squares. Let's go back to this. Manage animations. You hit the copy button here, right? Then you go to another animation player. You go to manage. You create the new library. And then you create a new animation. No, sorry. Then you hit this paste animation to library from clipboard, which is a built in clipboard. So that's something new. All right. I did not know that. So that pulls in the actual animation. So we're good now. All right. Next, make sure the autoplay button is selected and the loop button is selected. Okay. That's all done. We can change the playback speed based on the creature's random speed. Open the mob script. At the end of the initialize, right here, we want this. Copy. Wait, what? Right there. Okay. We save that. And with that, you've finished coding your first complete 3D game. Congratulations. In the next part, we'll quickly recap what you learned and give you some links to keep learning more. But for now, here are the complete player and mob. All right, let's take a look at the game. Look at that. Oof, oof. Look at him go. Look at him go. Woo. Look how awkward that looks. Ooh. Okay, so I have my guy a little screwed up here. Because after I jump, so let's kill me. So the animation looks good right here when I hop around. But when I jump, I get stuck in this state. So I would probably have to go back and fix that jump situation and why my Y is not resetting properly. But all right. So that is actually going to end up being the end of my stream. Whoop, sorry. F5. Oh, 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 oh. Come on. Ah, again. Sorry. Just want to keep going. Just want to keep going. I need to figure out how to export this game too. Looks fun. It's goofy. It's so goofy. Oh, I'm not good. How am I not good at a simple game like this? Oh, there's so many. There's so many of them. Anyway, that is our first 3D game in Godot. So we ran over time, which is unfortunate. So we didn't have time to actually start diagramming what we can start building next time, but that'll be fine. We'll do that the next time we have Coding Friday. So, but I do want to mention that next week, actually, hold on just a moment. Turn that off. Next week, I'll be moving my streaming time to the evening. So I'll be streaming from 9:30 to 11:30 most nights. Sometimes I might have to quit a little bit early because of, life and stuff. But I'll be following Darkest Levity after his streams. Tomorrow night, I will do a special stream for the Nope Jelly crew, where I will be continuing the casting of Frank Stone with Twitch integration, where chat will get to help make choices within the game. It's a horror game, or supposed to be a horror game. It was a little bit slow in the beginning. We're only in chapter 3, so I think it's going to continue to be a little slow right now. But if it does pick up, then I'm going to hate life. Because I don't like horror games. But anyways, tomorrow starting at 9 o'clock, we will go ahead and jump into that game as well. And we'll be doing that for the Nope Jelly crew. So hopefully y'all can stop by for that. And then again, next week, my stream times will be switching from the daytime to 9:30 to 11:30. And same thing as always. I'll be playing Dawn of Defiance, trying to get through the rest of that game. Wednesday, we will be jumping into another new game that I have picked out. And then Friday, we will start designing a new game that we can try to create in Godot on our own. One thing that I will try to find beforehand is some art assets that we can just use as stand-ins for some 2D stuff. That way we can just grab some free asset pixel art that we can just slap in there for now. But as always, I wanted to thank you all for stopping by and participating and helping me out in this. Darkest Levity, Quailless Dev, Space Horse, Did It Is Dishwasher. Really appreciate you all for stopping in, saying hi. Sky Panda, always. Thank you so much. I really appreciate you all. And as always, keep it simple and play games. Bye.